So I want to discuss a little bit more about tasks. Tasks also allow us to capture dependencies. What is a dependency? Dependency basically says that if I have a task A, I want task B to only execute after task A has completed. Dependencies are supported using #pragma OMP task depend, right? Using the depend clause. What is the syntax? So you can say depend in and specify a list of variables. You can say depend out, specify a list of variables, and depend in out and specify a list of variables. And what is the meaning of in, out, and in out? Think of it this way, right? In means that I am going to use this variable as input. And out means that I am going to write to this variable. I am going to produce this variable as output. I am going to update the value of this variable. The function need not necessarily update that value, but as long as you've specified that in the #pragma OMP task depend, OpenMP will take care that it follows certain rules. And in out says that I'm going to take this variable as input as well as write to it, update it. How do you use these, right? Let's see a simple example. This is a parallel region, and inside that a single thread does some work and it's going to spawn some tasks which are then going to be handled by multiple threads, right? That's the way tasks work. What am I wanting to compute over here? What I want to finally compute is I want to compute finalize f of x, g of x. That's what I want to compute. So how do I specify that? So this is the way to specify it. So I have these three variables x, y, z. Let's say that x is initialized to something first and then all of this happens, right? Then I call finalize fx, gx. X equal to init is put inside a task which initializes x. So it's going to specify x as output, right? Because it's going to set the value of x. Now that value of x has to be used by fx and gx. So there are two more tasks created, y equal to fx and z is equal to gx. And these tasks are going to depend on the value of x. So you say in x. Okay, and this also says in x. And what is this going to produce? It's going to produce output y. And this is going to produce output z. And finally this task takes as input y and z. So what does OpenMP do in this case? So let's understand the rules of OpenMP and then come back to this example. So how are independencies handled? So the generated task will be a dependent task of all previously generated sibling tasks that reference at least one of the list items in an out or in out clause. So what that is saying is that if I have a task, #pragma OMP task, and I say depend in colon x, what it's going to ensure is that all previously generated sibling tasks, what are sibling tasks? Tasks created by the same task, whatever tasks it has earlier created, and if it is at the top level then the thread, right?
In the concept of a parent task.
Yeah, so whenever I create a task, I am the parent task.
So I mean a task would know that somebody is created.
Yeah. What does #pragma OMP task wait do? It waits for all the tasks to complete, all the tasks that it has launched, right? So it has the notion of that these are all the tasks that I have launched. So all those tasks are called sibling tasks. Sibling means what? Brother, sister, right? So all those tasks are sibling tasks. What it's saying is that this task will be a dependent task. This task, whatever I'm going to do over here, I'm going to call a function g. So this g is going to be a dependent task for all the previously generated sibling tasks. Whatever tasks have been created before this by the parent task that reference at least one of the list items in an out or in out clause. Depend. In their out list they have x. Right? And similarly, if some task has x in out, then this task is going to be a dependent task of that task. So if this is, let's say, f and this is U. What that means is that G will not be executed until F and U are done. That means G is a dependent task of F and U. That's all it's saying. Why? Because this guy is trying to write to X and I have launched this task before, launching this task. And this task is saying that X is in out and I have launched this task before. So both these tasks may be updating X. So how can I execute this task which was launched later and it requires X as input? I cannot execute this task until those tasks are done. Alright? So it's just creating a dependency graph. That's what it's doing.
But does it actually matter to reorder because they're eventually sibling tasks?
No. So this is not sibling task. Will be a dependent task of all previously generated sibling tasks. I haven't even seen the tasks which are going to come yet, so I am not going to define any dependency with respect to them. So what is important here? There's another very important aspect over here. My dependencies should result in a DAG, directed acyclic graph. I don't want a cyclic graph. If you start looking at forward dependencies, you're going to end up with a cyclic graph. Okay? It doesn't make logical sense also. I mean, from a programmer's point of view, it is very counterintuitive, right, to do something like that. But this is quite intuitive, that if the programmer launched a task first and launched a task later, and if he had an out, something he was trying to write out in the first task and something he was trying to consume in the second task, then he wanted that dependence, right? So you don't want to execute these in parallel. Yeah, what does the second dependency say? It says that the generated task will be a dependent task of all previously generated sibling tasks that reference at least one of the list items in an in, out or in out clause. That covers just about everything, right? So what that means is that if I have, so depend out colon y, then any previously generated sibling task, if it had y in its list of in dependencies or out dependencies or in out dependencies, any of the three, this will be a dependent task of those tasks. It pretty much covers everything, right? If I see y in either in out or in out, I'm not going to execute this task until that task is done. Let's say I have these two tasks. This is producing some output and I call this first, and this is taking x as in. As you can see, this is writing to x and this is printing the value of x, right? So it's kind of like reading the value of x and this is kind of like writing the value of x. So note that if you specify these dependencies, right, that does not mean that you have to actually write to that variable and you actually have to consume that variable, right? You write the code that you want to do, but that's typically what you end up doing. So what will happen in this case? What will be printed? Let's say I have x equal to 1 outside. So what will be printed? Two? Always? Right? You will never see 1. Right? Because this is a dependent task. Okay. Now let me change this slightly. So let me say that this is in and this is out. I say x equal to 2 here and I print the value of x. What will get printed? What is the dependency for out? All previously generated sibling tasks which refer to x will be executed before this task is executed, right? So I'll definitely be printing before I execute x equal to 2, which means that I will always be printing the value 1. Okay. Now let me change this to out. Now what will happen? Still 1, right? Because this task, the dependency says that all previously occurring siblings, even when it is in, out or in, out, right? Any of the three, they will be executed before I execute. And finally, what will be printed? Yeah. So these two tasks can execute in parallel. Any one of them may finish earlier. So in this case, depending on which order they execute in, you might see the output 1 or 2. Okay? Let's go back to the example. Now it will make a lot of sense. So what is this saying? This is creating a graph. What is this graph? So first there is this x equal to init, right? So there's some init that's going to happen, and it has an out of x, right? And then there is this y equal to f of x, which has x as an independency, right? So this is y equal to f of x, and similarly this z is equal to g of x also has an independency of x, right? And this has an out dependency of y, which means that any appearance of y in in-out or in-out list before this task has to be completed first, but there is no occurrence, right? So there is no other dependency. Similarly over here out z, but z doesn't appear before this, so no issues here. So finally this is going to have a dependency of y, this is going to have a dependency of z, and then this final task says depend in yz. So it's going to depend on both of these, and finally finalize is going to get executed here. Okay? So y and z can execute in parallel, nothing else executes in parallel. In a similar manner, you can pretty much take any DAG and you can design the dependencies for that. So this is, let's say that this is a DAG, right? So how do you do this? So let's say there's some function a here, b here, c here, d here, e here. So what is the in-out dependencies I should specify so that ABC can execute in parallel, D can execute in parallel to A, and then E must execute when all of these are done. For A, I can say depend out A. Okay, let me not call it the same thing. Yeah, small a. Right? Yeah, for B, C, depend out C, right? Depend out A for A, depend out B for B, depend out C for C, and then for D, depend in B comma C and out D. Okay, I suddenly started going capitals, huh? B comma C and out D, right? Okay, and finally E in A D. I don't need an out. Okay. For instance, let me say that I was trying to save some variables. Let me just take an example, right? Let's say that I said out A here, so that I only have to say in A over here. Let's say this is the change I made. What would happen? What would be the repercussion of this?
The fourth statement will also wait for the first one.
D would wait for A? That's the problem it will cause, because if A occurs in the list of in, out or in, out of any task before this, that task must complete. So A must complete before D, which is not what we wanted, right? But pretty much you can, generate any DAG that you want. Just associate a variable with each one of these and you can do it, right? Use that for specifying in-out dependencies.
Does OpenMP consider these as labels or these as variables?
Variables. You use these variables to specify the dependencies. Looking at these variables, OpenMP identifies the dependencies. ideally, if you're saying out x, your code is supposed to be writing to x. X is an output of your code, right? But that's not necessary. I mean, if you don't update x, you don't update x.
Variables and use them.
Yeah, you can use any. You can just declare any variables and use.